Hello everyone. Today I will discuss the next arithmetic operation, and that is division. I will not discuss how we perform division. I hope you already know that. Long division, there are other division methods, repeated subtractions. So if I start with 6 apples, you will agree with me, and you have to imagine these 6 apples as a collection of apples, or a group of apples, or a set of apples. I mean, it's up to you how you do this. I can see this. I can actually make subgroups. Yeah. First, let me write the expression, and then I'll tell you what I mean by that. I can have 2 groups, each containing 3 apples. Yeah? So this is standard multiplication, you know it. Yeah? But I can also see this as 3 groups, each containing 2 apples. And why I can do that? Because if I ignore the apple, if I ignore the denomination, if I look at 6, I know 6 is 2 times 3, and it is also 3 times 2. So if I now see this as 6 apples, as a physical example of 6, then I can view this as 3 apples as a separate collection, and that collection is twice. So I have 2 collections, each containing 3 apples. I can also view this as 3 collections, each containing 2 apples. And both these interpretations, what I'm actually doing is that I can view this as sharing. Yeah? So here, if I pretend that I know the number of groups, let's say I want to have 2 groups of equal size. Let me just write it. 2 groups of equal sizes. And you can say, okay, each group will have 3 apples. Here I can say, I start with 6 apples. I want to have 3 groups of equal sizes, and each group will have 2 apples. So this is, these 2 is called the sharing interpretation of division. This you will see why I call it division. Yeah. So you can see that in fact I'm dividing 6 apples among 2 groups. You can see this as 2 kids, 2 siblings, 2 persons. Yeah. So similarly, I can see this as 6 apples divided among 3 persons, 3 siblings, 3 children. And that interpretation carries the sharing. Yeah? You are sharing 6 apples among 2 in this case, and among 3 in this case. But there is an alternative view. I can also see this as, look carefully what I am doing now. I can just flip these 2. Yeah? 2 times 3 apples can also be seen as 3 apples times 2. Yeah? Similarly, I can see this as 2 apples times 3. Now this is a different viewpoint. Yeah? Here we are not talking about sharing. Here we want to start with 6 apples, and this time I pretend to know this. I pretend that, okay, I do have to divide this among groups, but I don't know the number of groups. I instead know the size of each group. Here, I pretended to know the number of groups, and the question was, how many apples does each group contain? Yeah, number of groups. Yeah, how many apples each group contains. So one of these will be known, and the other will become your question. Here, I pretend that I know this. Yeah? So I want to ask, how many groups will I have if I require each group to have 3 apples? Yeah. Similarly here, if I want to divide 6 apples among groups of apples, and if I require each group to have 2 apples, or each group to contain 2 apples, how many groups do I have? Do I need? 3 groups. Yeah. So this alternative interpretation, you can, because the word containing comes again, containing, yeah, it's called the containment interpretation. So you can now see division as sharing or containment. In both sharing and containment, you are talking about groups, but in sharing interpretation, the question is, so let me now rephrase all of this. Yeah? Because now we are talking about a new operation, division, which is kind of reversing what we do in multiplication. So we also need a new symbol. So let me just rewrite this. So the symbol we will use for division is this, division. Yeah? So if I start with the sharing interpretation and hoping that you understood what I meant by that example, I will have 6 apples, and if I want to divide these 6 apples or share these 6 apples among 2 groups, 2 persons, 2 kids, 2 sets, 2 collections, no matter how you see it, this operation means that the result will give you the size of each group. Because you know the number of groups, you know the number of collections. Here, this will give you the number of elements, the number of objects here, in this case the number of apples, in each of these groups. Yeah? You know the number of groups. So the answer will be, because you know 6 divided by 2, you know, this will be a number such that if 6 can be divided, so we know 2 times 3. Yeah? The question is, we know 2 times 3 is 6. So the answer must be 3 apples. I must write apples here, because the question is about sharing. Yeah? You share 6 apples among 2 groups. Each group contains 3 apples. This is the sharing interpretation. Let me now give you an example, and by this symbol I mean division. This time I want to flip this. This is now containment. So now the question is, I have 6 apples and I want to have groups of apples, which I don't know how many groups, but each group is to contain 3 apples. So I say, let me put brackets so that you know what I'm doing. This is now the containment interpretation. The question here is that how many groups will I have? I definitely am going to divide 6 apples among a number of groups. Which number? I don't know. What I do know is that each group will contain 3 apples. Remember, containment. So how many groups will I have? 2 groups. Because again, the answer is 3 3 times 2 is 6. Here, the only number I can have is 2 times 3 is 6. Why am I doing that? Because division is the opposite of multiplication. Because in each of these questions, whether I'm going with sharing or containment, I'm actually seeing something which reverses multiplication. So the answer is definitely 2, because here 3 times 2 is 6, here 2 times 3 is 6. The question is that 2. Will that 2 have any denomination? No, because we have the denominations here. Here I can only say groups, but so this is the containment interpretation. The containment. This is sharing, this is containment. If you really want to have a denomination here, we can also do that. We can also do that. Yeah? But let's leave that for the next video, because I want to keep these operations clean. I think one more example will clarify this further. Because you are playing cards, so maybe this is more exciting. If I have 52 cards, yeah, I can view these 52 cards as, and imagine you have 4 players, yeah? So, and let's say I don't want to write players at the moment, because that will complicate the situation. So let's say I want to divide these 52 cards into 4 groups. I mean, I'm sharing this among 4 players. So the question is, how many cards does each player receive? The sharing interpretation. And if you work this out, you know how to divide, you will get 13 cards. This is the sharing interpretation. And if you want to see this as a containment interpretation, I can say, if I want to, I pretend to know this time. Yeah? I pretend to have 13 cards. Yeah? I don't know the number of players, but each player is to receive 13 cards. So how many players do I have? Yeah? That is also. But you can also view this from another angle. I can also see the rounds, yeah? So we are distributing those cards. In each round, you give 4 cards, yeah? So this is the number of cards you give to those 4 players in one round. So this is like 1 round. Yeah? Now, how many rounds do you need to exhaust or to get rid of all those cards? And it turns out to be 13. Similarly here. So you should always have these 2 interpretations in mind when you are discussing division, because this is a very powerful way of looking at problems. That's it for today. In the next video, we will try to have some denomination to these numbers as well. Yeah, that will increase the utility of division. So wait for the next video.